I don't know, package for face recognition that I don't have. Can you deploy this to me and help me out? So it's like outside help that we can have in the cloud environment. Okay. So now that we are in the context, we will try to perform the deployment of the simulation with the Kubernetes. And then what my colleague Bartos will do is he will explain how OSM is actually deploying this KNF. Okay. So let's go back to our repository. Okay. Each step that we have been talking about is written here with a lot of detail. So we are now in here, stage 3. Okay. We are going to deploy digital twin with Kubernetes, with YBots, and WASWare 2. So for you to follow along with me, we need to have configured a Kubernetes environment in our system. Okay. So basically, we will start the Kubernetes, and we will also enable Modus. We will follow along by cloning the repository, as Bartos has already shown to us by doing git clone. And then what we will do is we will basically initialize the recipe. So Kubernetes works with recipes. Here, there is a recipe of what we want to deploy. So let me actually show you what are we talking about over here. This is our recipe. And this is what the Kubernetes is going to deploy for us. So let's go very fast over here. We are going to deploy 2 things. They are separated with these 3 little lines. So we are deploying here a service and something else. What is this something else? We will be deploying an image of WeBots. So basically, this is a Docker Hub image of WeBots that contains some operating system with the WeBots simulation that is open source available to us. So the Kubernetes will download this image for us, and then on top of it, we will need to install something else. What is this something else? We will install ROS 2 to be able to use the ROS 2 applications, and we will also install the ROS 2 WeBots interface. So this is the actual package that acts as a plugin between the WeBot simulation and the ROS, so we can communicate the WeBots with the robot. So these are all the things that the Kubernetes is going to do for us. And we will just do we will initialize this. Okay, so when you run this command, it will probably take a little bit of time, like 5 minutes, 8 minutes. So give it a little bit of time to download the image properly and to configure everything. And what we are going to do is we will follow along the tutorial. So I have already run this thing. So you can use this command, sudo micro-case Kubernetes get all, to get all the Kubernetes pods and service that are currently running on the system. So it will actually, for the password, you write ROS. And here is what we have currently deployed. So over here, there is a Kubernetes service that what it's doing is mapping port 1234. So port 1234 is the port that the WeBot uses for streaming. So this needs to be configured to be mapped out, so we can actually connect through our web browser through this port to get the streaming data. Additionally, what we have here is the actual pod with the simulation, with the ROS, and so on and so forth. So what we will do is we can connect to this image by using this command. So let's copy, let's paste it. And what we will do is we will change the container ID by the actual container ID. We can find it here. Let me copy it. Oh. Did I write it wrong? Okay. Okay, we are here. So we are inside the pod with the simulation and with the ROS. So let's do a list to have a look at what we have here. Follow along the tutorial. The first thing that we want to do is we basically want to source all the tools that we will be using. So first, let's have a look at what we have here. The first thing we have is the installation of ROS Foxy. Okay. So as you can see, usually ROS by default is down in OPT under OPT ROS Foxy. So what we can see is that we have the standard installation of ROS. In this case, it is not the desktop version, but the skeleton version of ROS, which only comes with the necessary things to run basic ROS applications. So this is more a lightweighted version of the system. So it's better for the container. So what we will do is we will source ROS to be able to use it from the command line. And we will use this command, source the route to the ROS system, and we will do setup.bash. Okay. Once this is done, we can use all ROS commands. Like for example, we can do ROS to topic list, and we can see all the topics that the pod is actually listening. So we actually have over here some simulation topics from the reports. Like for example, here we have CMD-bell, which is the movement commands for the velocity of the robot. Here we have photometry, inertial measurement unit, we have scan data, many other things. So we can get and manipulate all the information about these things for the robot to move or to perform any kind of action. So what else do we need to do? Well, we need to install the ROS2 to YBots interface. So Kubernetes has already done that for us. So what we will do is we'll go to our workspace that the Kubernetes has created for us. And this is our ROS2 workspace. Here, the workspace has already been compiled by the Kubernetes. And we have, as a proof of that, that we have the installation and the build folders. So these folders come along when the Qualcomm build has been applied. So what we are going to do is basically we are going to source our repository. So we can use everything that we have in our workspace through the command line. So let's do source ws install setup.bash. Okay. And now we are ready to launch the application. Okay, before doing that, let me actually show you what kind of tools are available for you to play around. So if we go to the workspace and we go to YBots ROS2, here we have a lot of folders that are interesting. So for this workshop, we are using YBots ROS2 TurtleBot, which is this one. So that folder will initialize a TurtleBot 3 robot with this environment for us. However, you may want to run a different world or a scenario, and this package that is provided by the community has other scenarios for us. Like for example, we have Tiago from Power Robotics, so we can launch a war with a Tiago robot instead of a TurtleBot. Okay, and then you have some other examples. So when we have this, we go back to our repository. We have done the sources, okay, and then the last step is to launch the simulation that we want to use, right? So this is done in a ROS manner. We have for ROS1 just ROS launch the name of the package and the name of the launch file. And for ROS2, the launch file is a Python file, and we will just write ROS2 instead of ROS. Okay. And additionally to this, we will be running this command. What this command is going to do, it will execute the simulation in a virtual screen. So the Kubernetes, the webots will not complain that it cannot find a display for the simulation. So if we don't include this, it will just say, I cannot display the information for you, I will crash. Okay, so we'll put this and we will launch the simulation. So as you can imagine, I have already been running the simulation all along, but let's stop it. And basically, we will just run the command. So we will paste it here. Everything is source, and we launch it. Because we are running the simulation in a container, it will take a little bit of time, around 1 minute, for the ROS to be able to communicate with the webot simulation. So let's wait 1 minute. It should arrive at the 24. And in the 24, it should start connecting. Okay, so we are ready. And now, following along, what we need to do is we have our simulation running in a container, but we need to visualize it. So we will go to this URL to visualize our robot. So we will do HTTP, and we will put the container IP, semicolon, port 1234, index HTML. So I will very quickly show you how you can get the IP of your pod. And then once we have done, we will just go to here and we will arrive to this page. So what we need to do here is we need to change the local host by the IP of the pod of the Kubernetes. So let's just write 10.1.76.58, semicolon 1234. We will keep the mode by default, and we will just say connect. Okay. It is loading the wall. It may take a few seconds. Okay, and here we are. So let's go back to the, by the way, we will be having a 5-10 minutes break after we finish this tutorial about the webots. So you can have a rest and ask questions. And then we will go back to the OSM deployment that Bartosz will present to us.
One more thing, Adrian, we have a question. Do we need to build the webot simulation using Colcon, or is it already built when we start the container?
Yeah, very good question. Thanks for telling me on the chat. So to answer that question, let's go back to the recipe of the Kubernetes. This recipe, we actually see that the Kubernetes is doing the Colcon build for us. So let me actually go through the commands very quickly, so there is no confusion. After downloading the image with the webots, what we are going to do is we will create a folder. This is going to be the workspace for us. We will do apt update to update our system. We will install some tools that we need, like curl, and then we will basically install ROS. We will need to include the source to download the ROS with the Git. Once we have that, we just install ROS Foxy base. Okay, we source the system, and then we also download the webots ROS2 interface. So here is the actual command: git clone. You may notice that this is not the official webots account. I will briefly talk later on about this, but basically I modified the package for the webots to